everyone. In this video, we're going to look into how to simplify a function using 5-input K-maps. So, just like the previous video, let me ask you this question here. When I have a function with 5 inputs, the number of squares or number of cells in my K-map is going to be what? It is going to be 2 to the power of inputs 2 to the power of 5 is 32 cells, right? So earlier what we had was a simple 4-input K-map, and what we did when we moved from 3-input to 4-input was we mirrored this image. We got like we got the top 8 cells. We mirrored that to get the bottom 8. We mirrored this 4 with the bottom 8 cells, and essentially we got a 4-input K-map, right? So how do we go from this 4-input K-map to 5-input K-map? So do we take this and mirror it on the bottom? No. If we do that, what happens is the fundamental rule that two adjacent cells cannot have a difference of more than one input is not going to be valid. So all what we do is we just take one more K-map and put it on the side and presume when we solve this 5-input K-map, we have to imagine in 3 dimensions. So in other words, for example, when we have a function f with inputs v, w, x, y, and z, what we are saying is this is a K-map with v is 0, this is a K-map with v is 1, and the same thing follows. My f is going to be on both sides, but what we are solving is we're thinking about this problem in 2-dimensional. In other words, we're thinking this K-map, the second K-map, to be on the top of the first K-map. Let me show you a problem with an example, but before we do that, let's write the minterm numbers. The minterm numbers are going to be the same as before. So we start with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Then come down here and start 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. That is how you write simple 5-input K-map and write the minterm numbers. So let me tell you one thing before we go further. You rarely solve a 5-input function using K-map. You typically solve functions with 4 inputs, and solving 5 inputs is done on rare occasions. But you just have to know the fundamentals on how to simplify this K-map. So we're just going to look at it briefly. So let's say we have a function f of v, w, x, y, and z, and sum of minterms is going to be 4, 5, 8, 9, 12, 13, 24, and 25. Let's input a simple 5-input K-map and solve this function. So what I did was same as before. In order to save time, I just created a simple 5-input K-map figure and inserted that here. In here, the same thing. I have my f function. My f I'm going to write on both sides, and as you can see, this is a K-map with v is 0, this is a K-map with v is 1, and according to the same thing flows here. The first column is wx is 0, 0, second column 0, 1, third column 1, 1, fourth column 1, 0, and the same thing follows. So let's write the minterm numbers first. I'm going to write the minterm number 4, 5, 4, 5, 8, 9, 12, 13, 24, and 25, right? Now, let's see here. Did I do it right? 4, 5, 8, 9, 12, and 13. Sorry, my mistake, guys. This is 4, 5, 8, 9, 12, 13, 24, and 25. Now, if you see here, we completed the number of ones in the K-map, so we have to form groups. Now, let's look into forming groups here really quick. So now I can form a group of these 4 ones, and probably I can form a group of this 4 ones and this by itself. But this is completely acceptable. But however, as I said, you got to imagine these two K-maps being one on the top of the other. If that is the case, you might be able to envision that these two cells, let me change the color a little bit so you can observe it clearly. You might observe that these two cells are going to be on the bottom of these two cells, right? Because if you see, Wx is 10 here, Wx is 10 here. The only difference is V is 0 here in the first K-map, V is 1 in the second K-map. So if we do this, you have a larger group of 4 ones. So we do this group, and I'm going to call this group 1, and let's see, and I'm going to call this is group 2. So when we simplify the function f, my f is going to be group 1 plus group 2. So group 1, let's look into that group 1. Group 1, the first thing input is V. In these two cells here, my V is 0. In this two cells on the right, my V is 1. So V is the same or different? It is different, so ignore V. Now, come to the K-map 1 again. My W is 1 in the first K-map. W is 1 in the second K-map. So it is the same. We write W. X is 1, 0 in the first K-map. X is 0 in the second K-map. X is the same. So we write X bar. Y is 0 in both the rows of the first K-map, and Y is 0 in both the first and second row of the K-map too. So we write Y bar. And Z is 0 in the first row of the first K-map, and Z is 1 in the second row. Z is changing, so we forget about Z. Now comes probably your group 2. So how do we write group 2? My V is 0 in the entire K-map 1. So these 4 ones are completely on K-map 1, right? So we write V bar. W is 0 in the second column, and W is 1 in the third column. So W is changing, so ignore W. Come to X. X is 1 in the third column, X is 1 in the third column. So X is 1 in the second and the third column, so we write X. My Y is 0 in the first row, Y is 0 in the second row. Y is the same, so we write Y bar. Z is 0 in the first row, Z is 1 in the second row. Ignore Z. So when you have a sum of minterm functions with so many minterms here, using a 5-input K-map, you could simplify it from how many literals would you have here? Think about it. You would have approximately 35 literals. You're going from about 35 literals to just 6 literal function. That is the efficiency of a K-map. With that, I will stop with this video, and when we meet in the class, we're going to talk a little more and solve a few more problems on 5-input K-maps. Thank you.